Mine should have it. All right, so first thing I want you to notice. Give me your Chromebook. I don't need your charger. First thing I want you to notice is that what form are these written in? This first question. Factored. Okay. So this is in factored form. The other thing I need you to notice is that it equals what? Zero. Zero has special powers. Okay, it's got to equal zero. So down, and we had some questions on the last homework, and people came up and said it doesn't equal zero. What should I do? And some people I said make it equal zero, and some people I said you can kind of work with it, but for what we're going to do today, it's got to equal zero. So when we get down to this question right here, we get to this one, we're going to have to make sure that that equals zero because zero has special powers. What is the special power that zero has that doesn't work for any other number?
It's not negative or positive.
Okay, not negative or positive. Yeah. When its exponent makes it one. Okay. Kind of reading my mind. What else is true about it? I'll give you a hint. Multiplication. Anything times zero equals zero. So if I have one thing being multiplied, Luke, will you close your Chromebook, please? If I have anything being multiplied by zero, then I don't care what the other thing is. Okay. So what I'm getting at is this is multiplication between the parentheses. If I can get the first thing to equal zero, I don't care what the second thing is because zero times any number is zero. Okay. It's the only number that does that. If you multiply by 5, it's going to not give you 5, but 0 will always give you 0. And that's what we're trying to figure out is when does it equal 0? So I want to know, when does this equal 0? Yeah, 1/2. You could look at it and figure it out. You're less likely to make a mistake if I actually go, I want to set that thing 0, add 1 to both sides, divide by 2, and we get x equals 1/2. We're going to make mistakes there, like is it positive or negative or things like that. But if you write that out, you'll probably be fine. 1/2. If I plug 1/2 in here, I get 0. And then over here, I get 3.5. 0 times 3.5 is 0. So this is a solution. Can somebody tell me what they think the other solution is? Brody? Nope. -3. So we do the same thing with the other parenthesis. We're used to seeing the plus minus 1/2, but that doesn't happen unless it's the most basic form. So I don't really feel like I need to write this down, but this is what's happening. I'm saying I'm making that equal to 0. I'm subtracting 3 from both sides. I get x equals -3. So there are my two solutions for that problem. Okay. You could have thrown this into Desmos and it would give you the same answers, but if it were to say show work, you need to show that this work to show that you got it. So here's another one. Same exact concept. If I can make this parenthesis equal to 0, if I can make this parenthesis equal to 0, then I have my two solutions. Some of you might look at this and be able to go, oh, that's negative, whatever it is. Okay. But we're less likely to make mistakes if we just take a second and solve it. Plus, if it says show work, if it says solve by factoring, then there's an expectation that you're showing work and you're not just throwing it in Desmos. Strawberry lemonade?
Yes.
For now. Dun, dun, dun. Doesn't actually get too much harder than that. So this one here, what's the deal? What's wrong with that? Why can't I just go ahead and solve it like I solved the other ones?
It's in standard form.
It's in standard form. We need to get it in. And how do you get something in factor form? You factor it, right? So we got 64 and 16. Let's not smell our neighbor's shoes. No cross group smelling of shoes, please. Yeah. 8 and 8. Okay. So the factored form of this, because there's no number in the front, right? Then we can just say it's 8 or x plus 8 times x plus 8 equals 0. Hooray. X equals
Negative 8.
-8 or x equals -8. This is this means the vertex is on that. This only is one solution when the both solutions are the same. What don't we like about B? That's not the problem. We don't have any special tool for 64. So what do we got to do? Kill it. How do we kill it? Subtract it. We want to go ahead and say x squared minus 12x minus 64 equals 0. If we can get it to equal 0, then we can use this trick. We need to factor. Negative 64, negative 12. Calculator? It's not something easy, is it? 64 divided by 4. Negative 16 and 4. X minus 16 times x plus 4 equals 0. X equals 16 and x equals -4. I don't really need to show work on these. I only really need to show work if there's a number in front of the x.
When it's just like x minus 16 x. Like,
how did he get that?
Yeah, I know how to get it. Like,
he got it faster than me.
To me, I always just put it in a box, and that's how I get the x minus 16. Whereas you don't have to.
You don't have to put it in the box if a equals 1.
Yeah.
Right? So if that's equal to 1, then we know these are the numbers that are going to end up there. Putting it in the box, totally fine. Okay. All right, next one. What don't we like about this one?
56x. It equals 6x plus 2.
So I'm going to just throw those to the other side. Move the 56. Generally, we like the x squared to be positive, but it wouldn't be wrong to move to the other side. So, I think there's a GCF, isn't there? 2 would be our GCF. I would do positive because we really want this first thing to be positive. Okay. So it's going to be 2 parentheses. I kind of shouldn't have put my x there. 56 divided by 2 is 28. 28x squared minus 3x minus 1. Makes it a little easier to deal with. Negative 28 and negative 3. Two numbers that multiply negative 28, add 3. I go to my calculator, and I'm like 28 divided by 4. And there we go. We got 4 and 7. 4 and 7 where 7's negative.
Yep.
We have to use the box. Why? A is not 1. 28x squared, 4x negative 7x minus 1. We do GCF across. This would be 4x. This would be 7x. Some of you like to make those negative. We don't make these negative if this box is positive. 1, negative 1. So it's 7x plus 1 times 4x minus 1 equals 0 plus the GCF. Here's the question. We want to know when does this thing being multiplied equal 0, right? When does this thing equal 0? And here's the last question. When does 2 equal 0? When does 2 equal 0? Never. So this 2 out here does nothing for us. No. We just did all that work to undistribute it, right? So I know it's so tempting to want to put it back in, but no. So we want to know when does 7x plus 1 equal 0? Subtract 1 and divide by 7. Sorry, I kind of didn't give enough room. Negative 1/7. I find it dangerous to do this in your head, but can you do that one in your head? What do you get?
I say this all.
1/4. It's positive. I'm only not solving it because I don't have space, but you're more likely to make a mistake if you try to do that in your head. Okay. What don't we like about this one?
It's like the last one.
Okay, what should we do? What do you think I would do? WWMD.
Yeah, I would plus 5x. So then
Yeah, like I like x squared. Yeah, I like x squared to be positive. So if we move it this way, then we can say 0 equals 5x squared plus 15x. Does it bother you that 0 is on the left?
No, it's okay.
It bothers me a little, but it doesn't like make me have to not solve it. GCF is what?
3.
How about 5x? Pull out a GCF.
Oh, you're just. Wait.
GCF, I can pull out a 5 and an x out of each spot.
Okay. Yeah.
How do you know that something is completely factored?
If there's only one.
If you plug, if there's only
Kind of. I think you're saying what I'm looking for. Yeah.
If when it's distributed and you like solve it, then it goes out to 0.
Okay.
If there's no exponents.
No exponent. Well, the exponent's what?
There's 2 of x.
Yeah. What's the exponent on that x?
1.
1. When the exponent is 1, in a sense. Yeah, good. So we can't factor because when we have an x squared, we break that up to something x, something x. Okay. So this is where we want to say the solution is x equals -3. Last time I said when does 2 equals 0? I was told it never equals 0. I agree. When does 5x equal 0? When x equals 0. So that's different than that last one because you can make that thing equal to 0. Easy peasy. Here's the thing about these. Could you imagine if you weren't good at factoring? This would be very hard. And it scared me a little bit that some people turned to their neighbor and gave them the look like, see, you should have learned it. Okay. What?
One of my favorite things to learn is
Long division?
I hated long division.
You'll do
No, I hated long division.
You'll do long division with polynomials, and it's really cool.
Yeah, I'm scared too.
One of the parents said during conferences last week for algebra,
I want to hear this.
she said, "Do you know Math Papa?" And I was like, who is that? Is that right? Math Papa? Is that what it's called?
Yeah, I know.
And
I never used it.
Yeah. And I was like,
Dominic.
and then they explained what Math Papa was, and I was like, oh,
It's like one of those things that like it doesn't give you the answer, but it helps explain it to you.
yeah. It terrifies me if you Math Papa'd through factoring because you're gonna do it forever.
Wait, that Math Papa does factoring?
Yeah.
I didn't know that.
Yeah. So it'll help you, but when you take the test, okay, good talk. Okay, what does it say in the top right hand corner?
Raise.
Let's race on that, just that first one. I do want some coffee.
At least he's honest.
Who's honest? Math Papa. They said, do you think Math Papa is good for my child?
Not GCF.
Can you take a really
Such a weird name too, Math Papa.
Oh, I love
Like-
Math Papa.
Who's your Papa? Math Papa.
Hey, I found it. I literally gave you that.
Oh my gosh, you wizard.
Math
Sorry,
Papa.
Don.
Yes.
Be nice. Ooh, this one's kind of tricky.
I can figure that out. Yeah, I can figure that out. You're a wizard, Harry. I'm a what? A wizard.
That's funny. Math Papa and me like to climb up trees. Oh, I did that wrong.
Of course you know that part.
Did I get it right?
Oh wait.
Hold on, I'm almost done.
So you don't have a GCF. I'm not.
There was no GCF.
Yeah, there wasn't a GCF.
I told you this.
I know, I listened to you.
But that's like the only thing Dom said this whole time.
That's the only thing
Yay.
You're almost there.
Okay.
Finally said.
For a second I got scared, but I just like it.
I don't
It's
think.
because I circled it. You did it.
Yes, I did.
And my circles are better. I'm like a C.
We ready for the next one? Luke, can you close that, please? Actually, you can keep it open. That's fine. All right. So, are we racing? Did you already finish?
Are we racing this time?
Yeah, that was your head start.
Oh, wait, what? You need more coffee.
Wait, pause.
I wasn't ready.
Okay, never mind, now you can drink coffee. I think you ran out of coffee.
It's very hot this
Y'all are
morning.
hating on me for looking up. Both of you both looked up.
Shut up. I just have to get it started.
There is a GCF.
It's two.
Yeah.
Two of them.
Well, technically it could be negative.
How do you do that? Oh, it's.
Oh, yeah, he remembered.
Oh wait, it's one. Oh, this is easy.
That's not how I did it. I took the 16.
And I circled it before Maya.
It shouldn't matter how you solve it, whether you took the
Wait,
16
if
over.
the
But
A's won, if the A's won, then it just. I did it right. Wait, should that be a negative 8?
this,
Yeah.
this is the negative 8. What makes that 0?
Oh, sorry, I meant positive. Yeah, that makes sense. Sorry. Oh,
Did I get it right?
I might have put negative 8. Yeah, that's what I got. Because since A is 0, then
Strawberry lemonade?
Actually, it's a
It's-
mango loco
it's-
juice monster.
Wait, who's your final?
Bro, I literally thought about
That ain't supposed to be positive. The 16, whenever you take 16, it should be positive, right?
I moved these things to the right.
So are we not supposed to do 16 to the left?
You could. Did you pull out a -2?
No, I pulled out a positive 16.
No, when you pulled out the GCF.
Yeah, I got a positive 2 for GCF.
This is how I would have done it if I went the other way. I would have pulled out a -2, which would have given me x squared minus 7x minus 8.
Okay, thank you.
You're welcome. I want to skip this problem. I want to come back to it because I was looking at it earlier and it was confusing me. All right. So we just learned 3, 2, 1. Done, that's the point. We just learned that if it's in factored form, right, then the zeros are here. This is where it gets a little confusing. If the 0 is -8, then what was the factored form?
sorry, what?
I'll say it again. If 8 was the -8 was the 0 or the answer to make it equal to 0, then what was the factored? If x is -8, then what was the factored form up here? What was in the parentheses?
8.
Positive 8. Thank you.
Oh,
Okay, right?
okay, I didn't know.
When if the answer was 16,
It'd be negative.
then it was -16 because we're saying 16 is gonna make it equal to 0. What would the parenthesis have to be? So here, the 0 is 3. The 0 is 9.
So it'd be x minus 3.
So that means, write this in factored form. This is an equation. Y equals x, I'm leaving space here for a reason,
Why is it an equation?
minus 3, I'll tell you in just a second, and x minus 9. Why is that an equation?
Oh, because it's modeled.
If I were to say 0 equals x minus 3, x minus 9, I'm talking about 2 x's, right? And that's it. If it's an equation, I'm talking about all of these x's. Okay? So that's different. Some of you will type this in the graphing calculator and go, why doesn't it work? Because this is just, you're asking it to answer it. As soon as I write this as y, and you say, I want to know, the question is, when does this equal 0? Then it'll graph it for you. Because you're saying all these different values. Yes?
Could you factor that to -1 just like when,
Say that again.
like for your GCF? I meant.
For your GCF. Oh, yeah, we need to know what our GCF is here. Is that what you're saying?
Yeah, like I was asking, like since the x's are already like distributed, could you just take out like -3 or whatever?
You can't, to take out a -3, that means everything would have a -3. I see what you're saying, but this would also have to have a -3. Okay. So I left space there because I got to know what my A is. My A could be 5, 10, 30, 1. If it's 1, I'm done. Anytime we're missing a value, we plug in a value we know, and it'll tell us what that other value is. Tell me a value that we know from this graph. We can't use the zeros because that does that trick and makes everything just disappear. What's the value of -3? I don't know what -3 is. It's way up here. What's a value I know on here?
6.
6. What is 6 going to give us? I like that one. 6, -8. Anytime I'm missing a number from my equation, and we've done this a bunch, clearly -9. Anytime, all we need to do is plug in that one number. What do I mean? I'm going to go here and I'm going to say -9 equals, I don't know what my A is. We need to be a little bit more focused and a little less chatty.
You should give them a point.
Okay, thank you. Yeah. Parker, can you focus? Refocus?
Yeah, I'm not good.
Thank you. So I don't know what A is, but I can plug in a point to tell me. We've seen this a bunch. Then I need to solve this. So -9, this is multiplication. A times 3 times 3? Negative. Thank you. So that means -9 equals -9A. Divide by -9. A equals 1. So this time our GCF is actually 1.
Doesn't that mean it's just the same thing?
It's just same thing. Did I have to write the 1 there, Brody's asking? No, I didn't have to write it there, but I had to figure out if there was a number there. Okay? Because these zeros will tell us that it hits 0, but it's not going to tell us how wide or narrow it is. Okay? I know this next one is not going to be 1. How do I immediately know?
Because it's negative and a positive.
Okay. Nope. How do I know it's not going to be 1? I'll give you a hint. How do I know it's not going to be a positive 1? Because it's going down. So I write on here, I know that my equation is y equals, I like to leave a blank here. That way when I'm done, I just fill it in. X. My zeros are -5 and 1. Somebody tell me what to put with that X. +5 plus 5, because if I plug a -1 in, it's going to make that 0. And X minus 1. Again, I know my A is not 1 because it's going down. I get to pick any point I want, except the 2 that make up the zeros, because it'll do weird things. Yeah. Yeah.
The y-intercept.
Okay. You want to use this point right here. So there's my X, there's my Y. I don't know my A. So I go 2.5 equals A times 0 plus 5. That's kind of nice. Are you okay if I just write 5 in there? 0 minus 1, -1. So then I get 2.5 equals -5A. What are we okay over here?
Yeah.
A lot of whispering. You know what rhymes with whispering?
Attention.
I think so. Divide by -5. I should write a rhyming book, don't you think?
Yeah.
You know?
I'm kind of so glad.
2 fish, 3 fish, detention.
Yeah, pretty much.
Jack and Jill went up the hill, detention.
Instead of
Mary
going to school,
had-
Detention. Jack fell down, broke his crown, detention.
I love that.
Old McDonald
It's
had
very
detention.
Isn't it good?
This is the next Dr. Seuss that we're looking
I know.
Old McDonald had.
Once in a generation kind of thing.
Yeah.
So A equals -1/2. When I solve this down, I go back up here. I like this method where I left the blank, and there is that equation. How could I check this?
Putting it into Desmond.
I would love to plug this into Desmos and make sure that it hits all those points that are indicated there. I really like this next question. I did write it. It's a little wonky because I did. Our next one. So we have a quadratic. So it's going to be a parabola. I tell you that the vertex of this equation, this is where it's a little wonky because it's not an equation unless I write y equals. But if it was an equation, the vertex would be -3, 5. And one of the solutions is -8. Can you tell me what the other solution is? I can't do it without drawing a picture. Okay. But if I draw a picture and what do you think I need to have on this picture? I need to have the vertex. So the vertex is 1, 2, 3, -3, +5. And then I tell you that -8 is a solution. -3, 4, 5, 6, 7, 8 is a solution. Is one of my zeros. Can you tell me what the other one must be? I think I got it.
2. +2.
-2, positive, or no, +2.
I think it's +2.
What are you find it?
What did I say?
So we know that this is going to be exactly the same on the other side. Okay? So this went 1, 2, 3, 4, 5, and then landed. So we go the other way, 1, 2, 3, 4, 5, and land. What would that value be?
2.
You're going to have to help me with this last one. I'm a little confused on it.
Same.
Did you do this?
We did. I'm excited though. It's good for me to not know everything. Here's what I hate about these problems. And I even think I did a bad job on the last test. And I actually gave credit either way. Is anyone not taking the test in here yet?
What test?
Okay. There's a question on the test and it said, how high did the ball get when it was tossed? So I wasn't, when I read that back, I felt like it wasn't clear. Am I talking about when the ball was let go? Or how high did it get after it was let go? Right? Like what was its height value? Well, what I'm getting at is when they tell me a pitcher inside of a frame has an area of 375, is it including the frame?
Yes. No.
Yeah.
No.
It's just the picture inside the frame, not the frame.
Not the frame. That's what we decided? Okay, that confuses my brain. But we're saying that this 375, Hannah's saying, so if this goes sideways, you know who to yell at.
What?
I think it's saying the inside. Do you agree that the inside's 375?
Yeah.
You think so?
Yeah.
Ella, I want to know what you think.
I think that's what they mean.
Yeah. Okay. Obviously. Okay. So that's an area, and then they tell us that X is the width of the frame, and then when we get outside the width of the frame, then we're gonna have these measurements. Okay. So wants to know what the width of the frame is. What do you think?
I think it's 2.5.
Yeah.
30 times 20 minus 375.
Say again.
30 times 20 minus 375.
Okay.
25 area of the frame.
That'd be the area of the frame.
But you can still use that, right?
Kinda.
Wait.
The width.
I need to get my calculator.
Let me do this.
That would just give you the area of the frame. not the-
Yeah.
But you can
Given,
still use
I think I figured it out. Here's my hint. Given, you got a thought?
25.
I was gonna say find what multiplies to 375 and equals.
25 and 18.
Yeah, wait.
375
My
equals
brain
20 minus
is-
2x times 30.
All right. Good job, man.
That's right.
It is right.
What is it?
Yeah, we've already done. Haven't we already done problems?
Okay, so let me explain what Josh just said. Our answer, I really feel like our answer needs to be the area of the inside. Okay? If this is the length here, and this is the width, we really want to know talk about in terms of this thing. What is this length right here?
30 minus
30 minus this piece minus this piece. What are those pieces?
2x.
X. So 30 minus 2x. What's the other width? Yeah. 20 minus 2x. So now this is the area of the picture inside. It's kind of confusing because we're throwing the frame out in order to figure out the size of the frame. Are we being distracted over there? Maya, would you like to press charges?
No.
No. Okay. What is awful about this question? What's our trick? What's the number one trick we learned today? It has to equal 0. Why can't I just simply throw 375 to the other side?
Because it's already factored.
It's already factored. So what do we have to do? We have to unfactor it, move 375 over, factor it, and then we can solve it.
Oh, that's fine.
Yeah.
And that's when you use math.
Wait, why do we have to refactor it?
We can't just move this to the left because this is in factored form, and we don't. Then it would be minus that, and it would. So we got to unfactor it, move it to the left, get it to equal 0, and then factor it.
I don't like that.
I don't like it either, but let's do it. 600 minus 60x minus 40x plus 4x squared. I just foiled that. We okay?
Yeah. Now you have to subtract 375.
375. I don't know about you, but I don't like the order of this. So I'm going to go 4x squared minus 100x plus 225
Yeah.
equals 0. So I went ahead and subtracted 375. Kind of skipped that step. Now I can is there a GCF?
4.
You think it would be 4, but when I move this thing over,
0.
there is no
Actually,
GCF.
no, there's not.
Okay, so that's annoying. So my x, 225 times 4, we all know is instead of 900.
Yeah.
So what multiplies the 900 but adds the negative 100?
That would be, I don't know. I actually don't know.
Negative 50. Wait.
I think that's a question.
Oh yeah, it's negative 90 and negative 10.
Negative 90, negative
That
10.
was his idea, not mine.
Who's that?
That was,
Was that Math Papa back there?
yeah, he's
Math Papa Jr.?
Yeah, that's.
He's using math off on.
Very clever. So then we have to put it in the box.
He's using fun of math.
Don't take that away from him. So we go 2x and 2x, negative 5, negative 45. So now I can say, when does this equal 0? Here's a funny thing about quadratics. It always gives you 2 answers. Sometimes one of the answers is a bogus answer, but it's like it automatically goes, and this. It's called extraneous. What is extraneous? What word is in extraneous? Extra.
Oh, yeah.
Yeah, Brody.
2.5.
2.5 and
22.5.
22.5.
What?
Which of these is the extraneous answer? We just said that this width was x up here. Which one does not make sense? 22.5. We would not have the width be 20, right? And then this couldn't be 22.5 because then that means this width would be negative up here. What's that? Yeah. So this is the extraneous answer. We just put a little X through it. That means X equals 2.5 what?
Squared.
Centimeters. Not squared because it's a length. Aren't those fun?
Oh, and it wouldn't think if I did it online, I just thought that. That's, you know what we used to do. No, it doesn't work. It doesn't work for those questions.
Group quiz tomorrow.